Oh, if you're even, I don't know, is she like allergic, but it has to be a foodborne one,
She's both,
Oh.
airborne and foodborne.
ouch.
And then she got on the bus the other day and turned around, getting ready to leave and go out the door, and the back of the bus is just covered with mold.
It just didn't make any sense.
Well, then the bus driver that we know, in town, she said, well, they're all like that, because they're always damp.
Yeah.
So it just breathes there, and there's no way to get rid of it. It adheres to that metal, and you just can't even get it off without sandblasting it. Then you blast mold spores all through the bus.
And so we've got last section of chapter 8, or chapter 9, which is 9.8, and that is multiplication and division of complex numbers. And they're complex numbers because they have imaginary numbers and they have real numbers in them. You need to remember that every time you get an I squared, it's going to be equal to a -1. Because as we work with these for our multiplication and we FOIL stuff with them, we're going to end up with I squareds. And when you end up with an I squared, you just replace it, pull it out, stick a -1 in, multiply it by what's in front of it, and then you can combine stuff a little bit more than what we used to when we FOILed. A lot of times when we FOILed with regular equation or regular expressions, we came up with trinomials that had 3 pieces to them. As you noticed last time, we found some that did not have trinomials with them. So the first one we want to take a look at is 3 plus 5i, 2 plus I. So if I'm multiplying that together, I'm going to use, again, FOIL. So FOIL means I'm going to multiply 3 times 2 gives me 6. 3 times I gives me 3i. 5i times 2 gives me 10i, and 5i times I gives me a positive 5i squared. We all okay? Okay. So now, if I put stuff together, I have 6. 3i plus 10i is 13i. But this, remember, is a -1. So really, this piece plus 5i squared is really equal to plus 5 times a -1. So a -1 times 5 is really a -5. But now I need to go back and take another look at it and say, well, I can put 6 and a -5 together, and that's going to give me, what? 1 plus 13i. And so my answer comes out to be 1 plus 13i. And that's all I have out of that. Okay? So your combinations of stuff that you happen to have, you're going to get some things removed from those. So here's another one. What about this one? 6 plus 3i in parentheses times 2 minus 7i. So when I work this one through, again, FOILing, 6 times 2 is 12. 6 times a -7i is a -42i. Positive 3i times 2 is a positive 6i. Positive 3 times a -7 is a -21. And I times I is I squared. Are you good with that part? Okay. So what do I have? Well, I have 12. -42 and a positive 6 leaves me with a -36i. This piece is a -21 times a -1. So what's going to come out of that? Plus 1, or plus 21. So then when I add 12 and 21 together, I get 33 minus 36i. Make that look like a 6 there. And I get 33 minus 36i. Okay? So that's what happens with that one. So that's my piece. If it's got a radical with it, such as the square root of 2 minus I times the square root of 2 minus I, what's going to come out of that one? And it's a multiplication of like things here. Both of these two are exactly the same. What's the square root of 2 times square root of 2? 2. Okay. square root of 2 times the negative I is a negative I square root of 2. Negative I times square root of 2 is another negative I the square root of 2. And finally, a negative times a negative is a plus I squared. So then, when I have all that, what happens? Well, 2, negative 1I and a negative 1I square root of 2, and another negative 1I square root of 2 is a negative 2I the square root of 2. Square root, or x squared, or I squared, I should say, at the tail end leaves me with a negative 1. So my answer is really 1, 2I, the square root of 2. Okay or not okay? Not hard. These aren't too bad, are they? Once you get that rule down of what happens to your I squareds, they have a tendency to work out quite well, and you can come up with what your answer happens to be. What if we have this one? 2 minus I times 2 plus I. 2 minus I times 2 plus I. What's going to happen with that one? What would I need to do? Well, I need to FOIL. 2 times 2 is 4. 4 times I, or 2 times I, is a plus 2I. Negative I times 2 is a negative 2I. Negative 1, or negative I times a positive I is a negative I squared. So what do I have? Well, I got 4. What happens to this stuff in the middle? Goes away, because what you have up here, remember we talked about that a little while ago about conjugates when we got rid of common denominators and made our or removed denominators within our radicals. This and this times each other, of course, makes the middle thing disappear. And then what happens on the end? I have a plus 1 because it's a negative I squared, or a negative 1 times a negative 1, which is a positive 1. Or my full answer to this is just simply 5, and you're done. Okay? Pretty straightforward, pretty easy stuff there. So I end up with just my plain old 5 in there for that one. And so that's what these conjugate pieces do, of having opposites. And we know how to create them. So let's say if I gave you 5 plus 3I, and I want its conjugate. I want the thing that matches it, that makes the center go away. What would I put? What would it be? 5 minus 3I. And then if I FOILed that out, it would end up going away, because the negative 15I and the positive 15I disappear. And then finally I'm left with a negative 9I squared. And so really I have 25 plus 9, and if I add those together I get 34. And so it came out to be a straight number with no imaginary things in it at all, which is nice when that happens, because they all disappear at that point. Okay or not okay? Questions? So far so good? Alright. So we'll keep moving along here. Because now what it does in this section, are we okay with the distribution stuff? That's good? Okay, and doing that, the foiling and all that stuff? Alright, excellent. So if we're good with that, then we'll move on to a division problem. So if this were my division problem that I'm given, we practiced back in, what was it, 9.4C, I think it was, where we took care of denominators and we removed that stuff out of there so that we could get rid of and have a straight denominator with no radical things left in it. So the same thing happens here. So if I'm going to do this, I'm going to multiply by its conjugate. Well, we just found out that meant a negative 1 plus 5i because of its conjugate. But if I do something to the bottom, I also do it to the top. So negative 1 plus 5i goes on top as well. And because it goes on top, what am I left with for this answer? Well, 4 times a negative 1 is negative 4. 4 times a positive 5i is 20i. And what do I have in the bottom? Well, I know with conjugates the middle disappears, so I don't have to do that part. Negative 1 times a negative 1 is a positive 1. A negative 5i times a positive 5i is a negative 25i squared, which really is positive 25. So I have negative 4 plus 20i all over 1 plus 25, or my answer is a negative 4 plus 20i all over 26. Now, they're going to look at it, and Hawks is going to pop back up and say, yeah, Jenny, you're right on the ball there, because we got to reduce it. Because what does it reduce to? Well, in the top, I can pull out a 2 and a 2 for the bottom. You want to look at common things. I could pull out a 4 in the top and a 2 in the bottom, but it's not going to help me pull out a 4 because I got to go back and multiply it together. So if I pull out a 2, I get negative 2 plus 10i all over 26. The 2 and the 26 will cancel. So really my true answer is a negative 2 plus 10i all over 13. Okay? Now the thing you can do, if you had this piece up here, we can do what's a triple cancel. The only time you ever get to do that is in this situation, because really what this is showing you is a negative 4 over 26 plus 20i over 26. So that cancellation that's in here, I can cancel these guys and I can cancel those, okay? And so if you do a triple means I'm going to look here, here, and here, and it's the only time we ever do that. We never do it anywhere else. I could cancel this out and have a negative 2, cancel that out, get a 10, cancel that out, and get a 13, if you want to do that triple canceling. But don't hop into regular fractions and start doing triple canceling, because you're going to end up in trouble with that. But it is still the same thing, because notice it's still a negative 2 over 13. It's still 10i over 13. So this all comes back to be what we had in the first place. Okay, so you can do that triple kind of cancellation stuff in there. And you can do that. We're going to use that same kind of thing in chapter 10, because in chapter 10 we've got some stuff that does the exact same stuff in there. So what about this one? Square root of 3 plus I all over the square root of 3 minus I. What are we going to get with this one? I'll move it up a little bit. What happens? So we need its conjugate, so what's that going to be? Square root of 3 plus I. And then basically it's just 2 foilings that are going on there. Although the bottom, you do not need to do everything, just the square root of 3 times the square root of 3 is 3. Negative 1i times a positive 1i gives me a negative I squared, which is really a negative 1, but it's a negative out in front, so it changes signs. Be careful with that. That's usually the number one mistake that's made, is you forget to change the sign there. It's always going to change the sign in that location. So then, FOIL the top. Square root of 3 times square root of 3 is 3. Square root of 3 times I is a plus I, the square root of 3. I times the square root of 3 is another plus I, the square root of 3. And finally, I times I is a positive I squared. And what comes out of that top part? I guess I can't write it in that one space I had. I'll bring my 4 down here. 3. This I squared, remember, is going to be a negative 1. So 3 plus a negative 1 is 2. Positive 1i, a positive 1i with a square or a 3 after it gives me really plus 2i to the square root of 3. Now, what about this one? Can it cancel? It can cancel too. because 2, 2, 4, I can pull out a 2 out of everything that I have there. So the 4 becomes a 2, this becomes a 1, that becomes a 1. So my answer is really 1 plus I, the square root of 3, all over 2. Okay? So that's what that will be for that one. Alright, make sense? Hopefully. Okay, let's do another one of those so we got a good grasp of what we have happening with that. Square root of 2 plus I all over negative square root of 2 plus I. So what happens to this thing? So what do I need for it? Conjugate, yep. So negative square root of 2, what's going to go next to it? Minus an I. Nope. Nope, you do not change. The only sign that changes is the center one. This is the only piece that changes when you do a conjugate. Nothing else changes. It's going to stay that as what we have with it. So, what happens? Square root of 2 times the negative square root of 2 is a negative 2. Square root of 2 times the negative I is a negative square root of 2 with an I out in front. I times that is another minus I the square root of 2. I times a negative I is a negative I squared. Always write that out first. Don't hop in and change it right off the bat because that's when you miss signs. Okay, so be real careful with that one. And so we'll finish up what we got on the top and then we'll go to the bottom. Negative 2, this is going to become a positive 1. So negative 2 and a positive 1 is really a negative 1. Negative 1I square root of 2 and a negative 1I square root of 2 is really a negative 2I the square root of 2. So that's what's in top, because I move this piece over there. And then the bottom, negative square root of 2 times negative square root of 2, positive 2. Positive I and a negative I is a negative I squared. This becomes really a negative 1, but that negative in there makes it a plus 1. Whoops. So really, I have 3 on the bottom. Is there any cancellations? Nope. Nothing cancels. Okay? When you are in practice, Hawks will tell you if you have to do a reduce and reduce it. I don't think they do in Certified, though, because I think they expect you to know what in the world you got going on in there. Okay? With that one. But that's the basic stuff of all this. Now, can you end up with not having a whole lot to combine? Yes. And one on that order, we're going to go back and do this one. Negative 9 minus I the square root of 3 times 8 plus I the square root of 6. So what in the world's going to happen to this thing? Well, it's kind of taken everything we've done and thrown it into one mix. Negative 9 times 8 is a negative 72. Negative 9 times I is a negative 9I the square root of 6. Negative I the square root of 3 times 8 is really a negative 8I the square root of 3. And last, negative I times a positive I is a negative I squared. What's the square root of 3 times the square root of 6? Square root of 18. Yes, because I multiply them, right? So I got to put it back under that radical. So, does it look like anything goes together? So this one kind of looks like a big mess, doesn't it? Because 72 I can't, negative 72 I can't put together. These two things I cannot put together because they don't match. This thing, on the other hand, we got to work with that. So it's a negative I squared to square root of 18 because it's not simplified all the way. This negative I squared is really 1 times a negative 1. Negative 1 times negative 1 is positive 1. But 18 isn't broken down completely, is it? What can I pull out of there? Well, 18 is made up of 9 times 2. So I could pull out a 3 and leave a square root of 2. So really I have plus 3 the square root of 2 in that location. So is Hawks happy? Hawks is not quite happy yet because we want to put all of our real values together. So negative 72 plus 3 to the square root of 2. And then we want to put all of our I pieces together. So we have our real piece here, our imaginary pieces there. And then it does, in some cases, have you pull out what you can out of some of these pieces. And so I can put that together. And over here, I can pull out an I out of all this and make it negative 9 the square root of 6 minus 8 the square root of 3. And then you can leave it like that. And that would be your answer that you put into Hawks. So it's kind of tricky sometimes. If for some reason that you go through and you do this on your test, you type in that, I won't be happy, okay? Even though Hawks might mark it wrong because you didn't pull out your I will be happy, and that's where I'll go back in and fix those. But that's what you got to do with those. All right, so just be really careful about those ones that don't work out exactly to give you your answer. The other day we also talked about I to the 28th. That pops up in this section. I had it in the wrong section the other day. How do I solve that? Well, remember we were going to look for, because every square that I get is equal to a negative 1. So if I take 28, divide it by 2, I get 14. So it's a negative 1 to the 14th power. And the other day we learned that if this is positive, or not positive but even, if it's even, our answer is just simply 1, okay? If this is odd out here, you're going to have a remainder, so you'll always have an I left over. Then you got to determine whether that's going to be a positive or be even or an odd. An example might be I to the 27th. If I did I to the 27th, 27 is not even, so I know there's going to be an I left over. 27 divided by 2 goes in there once, goes into 7 3 times, with 1, which meant my I's left over, but then I have a negative 1 to the 13th power. When this is odd on a negative, it means I get a negative. So my true answer on this one is just simply a negative I, would be what my answer would be. So it's kind of like working binary numbers, really, because every time I get a 2.
Correct. 2 into 7.
Yep.
But the 3 goes on the top.
Oh, the 7 goes here. Sorry.
6.
The 3, yeah.
6.
Thank you for catching me on that. Yeah, because this should have been a 7 out of 3. I don't know why I was writing a 3 down there.
With the wrong letters.
Yeah. Well, thank you for catching that.
I'm easily
Mary Jo, that's great.
confused,
I know, but that's great. You caught that because, yeah, that was me not bringing down my 7. I thought 7. Then I was thinking 3 at the same time, so I guess I wrote a 3 instead. Yeah, because 3 times 2 is 6, leaving me with the 1 left over. Yeah. And so those are the conversions with that. Okay. Need to do more of these? You okay? Think we're good? Think we're good? Okay. I'm going to stop this thing.